Hi, Zach from BIMteriors, and today we'll be continuing with walls within Revit. When it comes to interior design and construction, precision and clarity are crucial. So this holds true in every aspect of the building, down to its very walls. In the world of digital design and BIM, Revit stands as a powerful tool, and understanding its complexity is essential. So today we'll be diving into wall assembly layers within Revit. So, what are wall assembly layers? In Revit, walls aren't just flat surfaces, they're complex assemblies consisting of multiple layers, each serving a specific, distinct purpose. These layers collectively form the wall's composition, so providing structural integrity, maybe insulation, aesthetics, and much more. Understanding these layers is crucial for precise design and accurate construction documentation. The anatomy of a wall assembly in Revit, walls are typically built up of various layers, with the core layer being the central structural component. And then also we have non core layers, which would be the additional elements added to the wall's composition for various purposes, such as insulation, finishes, or detailing. So here's a breakdown of what these layers typically consist of. One, we've got the structure layer. This is a central load-bearing layer of the wall. It represents the primary structural elements such as concrete or masonry, or this can be steel or wood studs. Then we have a substrate layer. The substrate layer serves as a base foundation for attaching other materials or finishes. This provides stability and support for various wall coverings, such as plywood or gypsum board. Then we've got the thermal slash air layer. In some wall types, an insulation layer is added for thermal performance. This layer will help regulate temperature inside the building. The cavity is the space between the core layer and the outer layer. It can be used for various purposes, including accommodating electrical or plumbing elements. Then we've got the finish layer. So these layers include materials like drywall, paint, or cladding that gives that wall its final appearance. So these are non-structural elements, but crucial for the aesthetics. There are two types of finish layers in Revit. We've got finish 4, which is the external finish face. And then we've got finish face 5, which is the external surface face. Lastly, we've got membrane. Membrane layers in some walls incorporate layers for air or vapor barriers to control the moisture and airflow within the walls. So these non-core layers allow architects and designers to customize wall assemblies to meet specific project requirements, such as insulation needs, fire resistance, or aesthetic preferences. So at this point, we want to create a new wall. We want to modify a wall structure. So click on an instance of a wall you want to change. The structure, keep in mind, if you use this workflow, that all of the walls of this type will be affected. So what I always recommend is to duplicate the wall type and name it with the new wall you'd like to create. So for today, we'll create a tile wall. Click on the edit type. You will reach a menu with all the type properties of this wall type. So depending on the wall that you've selected to duplicate, this will vary with your starting parameters. So currently this window, we have one structural layer consisting of our metal stud and a finish layer on either side of the gypsum finish. But now we want to add a layer to our new wall. We want to add potentially a grout layer and a tile layer to our new tile wall assembly. So to add a layer, you want to click on the insert button and add new material. Use this up and down arrow to move the material. Exterior side is top, interior side is bottom. And then this way here, you can position it according to your wall assembly and wall type you're trying to create. Now we can adjust our thicknesses. So change the value in thickness to match the material you want to add. So remember, you can use both units if needed. So maybe we have a tile of maybe it's 13 millimeters, and we've got a grout that can be anywhere from potentially 3 to 6. And so we can go and insert these right now. So at this point, we might want to change the material of maybe the existing wall that we've duplicated or the new materials that we're bringing in. On the material column, click to change the material you are using. You will enter material editor. So at this point, you can choose one of the materials provided in the template, such as tile or grout. So layers can also associate material properties for richer graphics and BIM data for analysis. Materials are important for a couple of reasons. First and foremost, materials allow us to assign hatching graphics and photorealistic materials for graphic displays and renderings. Secondly, it allows us to associate additional information with a material such as cost, manufacturer, keynotes, thermal, or physical properties. So, in order to calculate energy efficiencies, costs, quantities, counts, structural analysis, these additional parameters are important. Layer wrapping. The last column assigns the ability for layers to wrap around edges assigned by default wrapping sections. So only layers outside the core boundary can wrap at inserts and ends. The default wrapping section in the wall assembly editor controls how layers wrap at the ends of a wall or when openings such as windows or doors is placed within the wall. If the layer has the box checked, the material has the ability now to wrap at the ends and inserts. Wrapping at an insert refers to how material interacts with a family that creates an opening in a wall. Specifying this allows a greater control of how a jam detail looks at a smaller scale, which then can that can help to save time when drafting finishes. This also controls which materials, interior or exterior, wraps at the end of a wall. However, this does not automatically wrap embedded sweeps or reveals around the corner and will have to be adjusted manually. Lastly, we've got the modify vertical structure. The modify vertical structure section is key to more advanced wall assemblies by editing layers, adding sweeps, reveals, etc. This is a particularly useful tool and will be captured in more depth in a future episode. Why does all this matter? So, why does understanding wall assembly layers in Revit actually matter? It enhances design clarity. So, knowing the purpose of each layer allows designers to make informed decisions about material, aesthetics, and performance so that we can accurately interpret design intent and select appropriate construction methods and materials. So, to sum all this up, wall assembly layers in Revit are not just digital abstractions, they are the foundation of the real world buildings. So, by understanding and assigning functions to these layers, designers and builders can work together to create structures that are both beautiful and fun and functional, standing a testament to the power of precision design and collaboration. That wraps up wall assembly layers in Revit. So if you're hearing this message, you've listened to the new episode all the way to the end, and for that I thank you. Like and subscribe now to gain access to new Revit content weekly.